Geothermal energy, which harnesses the heat from within the Earth, is considered one of the most promising renewable energy sources for our future. But what is it exactly, and why does it hold so much potential? In this episode, we'll dive into what geothermal is, and how it might play a significant role in shaping our energy landscape moving forward. Join us in exploring this fascinating topic. Let's get started. To understand geothermal energy, let's start with the source, the Earth's core. The inner core is a solid ball of iron and nickel about 12,000 kilometers in diameter. It is incredibly hot, reaching temperatures of around 5,000 degrees Celsius. This intense heat originates from the formation of the Earth, the pressure from the weight of the overlying mantle, and ongoing radioactive decay of elements within the core and mantle. Now, here's the kicker. This heat doesn't just stay put. It actually transfers to the surface through conduction and radiation. While it's happening pretty slowly over millions of years, the heat eventually makes its way to the crust, the outermost layer of the Earth. And that's where we come in. We can tap into this natural process by drilling deep into the Earth and extracting the heat. But there are different ways we can do this based on how deep we drill and how we access the heat. Now this leads us to the two primary types of geothermal energy, which are hydrothermal and enhanced geothermal systems. As their names suggest, these two methods use different approaches to harnessing the Earth's internal heat. Let's first explore hydrothermal systems. As the name indicates, this method utilizes the heat from water that has been heated by the Earth's internal heat. We're talking about water that has percolated deep into the ground and absorbed the warmth from the surrounding rocks. Now you might be wondering, how do we get this warm water back? Well, it's not too far down, typically less than 6 kilometers. And Mother Nature has a way of returning it to us in the form of geothermal springs or hot water reservoirs. All we have to do is find these spots on the Earth's surface, which often manifest as hot springs, geysers, or areas of warm water discharge. Once located, we can build power plants near these sites to convert the thermal energy of the water into electricity. Sounds pretty straightforward, right? Well, it helps that the water is already warm. The process is simpler compared to the other method, enhanced geothermal systems. Let's now turn our attention to enhanced geothermal systems. This approach takes a slightly different route, but the objective remains the same, to access the Earth's internal heat to produce energy. The key difference here is that we're dealing with dry steam or hot water vapor rather than liquid water. Instead of searching for natural occurrences of geothermal activity, we drill deep into the Earth, typically between 2 to 10 kilometers, where temperatures soar above 180 degrees Celsius. These conditions are excellent for producing steam, which carries a substantial amount of energy. But wait, wouldn't that hot steam escape back into the Earth if we drilled a hole for it? You're absolutely right. That's why we inject water into the well. By forcing water into the hot rock, we cause the steam to expand and flow upward. This movement of steam drives turbines connected to electricity generators, converting the steam's thermal energy into electrical energy. Once the steam has done its job of generating power, it condenses back into water. This water is then collected and re-injected back into the Earth to maintain the pressure and temperature needed for steam production. And that's a nutshell, how geothermal energy works. So what makes geothermal energy such an attractive option for our future power needs? Well, it has several factors working in its favor. First off, it's a renewable energy source. Unlike fossil fuels, the Earth's internal heat is constantly replenished through natural processes, meaning it's a sustainable resource. But that's not all. Geothermal energy boasts an impressive capacity factor. What does that mean? Well, it refers to the percentage of time a power plant can generate electricity. For instance, if a plant operates at 90% capacity factor, it means it produces electricity for 90% of the time in a year. Geothermal power plants typically operate at around 95% capacity factor, thanks to the consistent supply of heat from the Earth. This reliability makes geothermal energy an excellent baseload power source, providing a steady stream of electricity to meet the constant energy demands. And let's not forget about its environmental friendliness. Compared to fossil fuel-burning plants, geothermal plants have a significantly lower carbon footprint. They emit very small amounts of greenhouse gases, mainly water vapor and carbon dioxide. Plus, they don't produce any air pollutants, making them a clean energy choice. Moreover, geothermal power plants occupy a minimal land area, reducing habitat disruption and visual impacts on the surroundings. They also produce little to no noise pollution, ensuring a peaceful environment for nearby communities. However, geothermal energy isn't without its challenges. One major hurdle is its geographical limitation. Not all locations are blessed with the right conditions for geothermal energy production. It works best in regions with high volcanic activity or tectonic plate boundaries where the Earth's internal heat is closer to the surface. For example, places like Iceland, Northern California, and New Zealand are prime locations for geothermal energy due to their unique geological features. But many other regions would need to drill deeper and more expensive wells to access the Earth's heat. Another concern is the potential for induced seismicity. In rare cases, the extraction of geothermal energy can trigger earthquakes. This happens when fluid is injected into deep underground wells. The increased pressure can reactivate existing faults, potentially leading to seismic activity. However, it's important to note that induced earthquakes related to geothermal energy are generally of low to moderate magnitude and do not pose a significant risk in populated areas. But there is hope on the horizon. Scientists are continuously working on improving drilling techniques and developing advanced technologies to make geothermal energy more accessible and efficient. So, while geographical limitations and seismic activity are valid concerns, they are not insurmountable obstacles. So how can we improve the efficiency of geothermal energy? Well, researchers are exploring various avenues to enhance the performance of geothermal power plants and extend their reach to new areas. Here are some of the exciting developments on the horizon. One promising avenue is the use of advanced drilling techniques such as horizontal directional drilling and rotary drilling to create longer-lasting and more efficient wells. These methods allow for the creation of wells that can withstand high temperatures and pressures, enabling access to deeper, hotter geothermal resources. But that's not all. Scientists are also investigating the potential of using carbon dioxide as a working fluid in geothermal power plants. This approach, known as supercritical carbon dioxide geothermal, offers an innovative way to harness heat from hotter and deeper geothermal reservoirs. By using carbon dioxide, which is a non-corrosive and non-toxic substance, it reduces the environmental impact and maintenance costs associated with traditional water-based geothermal systems. Moreover, researchers are developing advanced materials for use in high-temperature and high-pressure geothermal environments. These materials can enhance the durability of well casings and downhole equipment, reducing the frequency of maintenance and repair operations and extending the lifespan of geothermal power plants. Another exciting development is the integration of artificial intelligence and data analytics in geothermal exploration and power plant operations. AI algorithms can analyze vast amounts of geological and geophysical data to identify optimal sites for geothermal energy extraction. Additionally, real-time monitoring and predictive analytics can optimize power plant operations, ensuring efficient energy production and maintenance. These advancements in geothermal energy hold immense promise for the future of clean and sustainable power generation. By embracing innovation and investing in research and development, we can unlock the full potential of geothermal energy and pave the way for a greener and more sustainable future. Now the question arises, how can we harness this incredible power source to address our growing energy needs? One promising application lies in direct-use geothermal heating and cooling. By tapping into the Earth's constant temperature, we can provide efficient and sustainable heating and cooling solutions for buildings and greenhouses. Geothermal heat pumps extract energy from the ground to heat and cool spaces, reducing reliance on conventional HVAC systems. Moreover, geothermal energy plays a vital role in industrial processes that require high-temperature heat, such as in the production of cement, steel, and other materials. By utilizing the Earth's internal heat, industries can reduce their carbon footprint and move towards more sustainable practices. And let's not forget about the potential of geothermal energy for desalination. In coastal communities facing water scarcity, geothermal energy can power desalination plants to convert seawater into fresh water. This application not only addresses water needs, but also supports industries such as aquaculture and agriculture that rely on freshwater inputs. The future of geothermal energy is bright with possibilities. Continuous advancements in technology and exploration are expanding its potential applications and enhancing its viability as a clean and sustainable energy source. Embracing geothermal energy is a step towards a greener, more sustainable future. And as we continue to explore and innovate in this field, we can harness the Earth's incredible power for generations to come. So what are your thoughts on geothermal energy? Do you think it holds immense potential for our future power needs, or do you see other renewable sources taking the lead? Share your thoughts with us in the comments section below. And hey, if you enjoyed this episode and want to support our mission, don't forget to like and subscribe. Your support means the world to us. Thanks for joining us on this journey through the fascinating world of science and technology. Until next time, keep questioning, keep exploring, and keep learning.